Hi, I am Srinivas and this video is on the topic Principal Component Analysis. Principal Component Analysis is an unsupervised learning algorithm that is used for dimensionality reduction. It is a technique to draw strong patterns from the given dataset by reducing the variance. It is a statistical process that converts the observations of correlated features into a set of linearly uncorrelated features with the help of orthogonal transformation. These new transform features are called principal components. Principal component analysis works by considering the variance of each attribute because the high attribute shows the good split between the classes. Hence, it reduces the dimensionality. Here is a picture how data looks before principal component analysis and after applying principal component analysis. We could see there is a gradual decrease in the number of attributes which define the data. The mathematical concepts used in principal component analysis are variance and covariance, eigenvalues and eigenfactors. Terms used in principal component analysis algorithm: dimensionality, correlation, orthogonal, eigenvectors, covariance matrix are some terms used in principal component analysis. Dimensionality is the number of features or variables present in the given dataset. Correlation signifies how strongly two variables are related to each other. If one changes, the other variable also gets changed. The correlation value ranges from -1 to +1. -1 indicates that the variables are inversely proportional to each other. +1 indicates that the variables are directly proportional to each other. Orthogonal defines that variables are not correlated to each other. Eigenvectors is a square matrix M and a non-zero vector V. Let us consider there is a square matrix M and a non-zero vector V. Then V will be eigenvector if AV is the scalar multiple of V. Covariance matrix. It is a matrix containing the covariance between the pair of variables. Principal components in principal component analysis and their properties. The output of principal component analysis are principal components. The number of principal components are either equal or less than the original features present in dataset. Some properties of principal components are: principal components must be linear combination of original features. These components are orthogonal, that is, the correlation between a pair of variable is zero. The importance of each component decreases when going to 1 to n. It means that the one principal component has the most importance and the NPC principal component will have the least importance. This is this is a flowchart that depicts how principal component analysis can be done. Firstly, we collect a data and we transform it into a data matrix. Then we calculate the covariance of the matrix and the correlation of the matrix. We calculate eigenvalues and eigenvectors for the calculated matrices, and then we calculate proportion of total variation. Then we rescale the principal components and choose the number of principal components which define the given data set. Then we generate plots and we generate the data set. Steps for principal component analysis algorithm. Firstly, we get the data set. We need to take the input data set and divide it into two subparts, x and y, where x is training set and y is validation set. Representing data into a structure. The taken data set will be represented into a structure such that we will represent the given data in a two-dimensional matrix of independent variable x. Here each row corresponds to data items and the column corresponds to the features. The number of columns is the number of dimensions of the dataset. After performing the second step, then we move on to standardizing the data. Here in this step, for every particular column, the feature with high variance are more important compared to the feature with low variance. If the importance of features is independent of the variance of the feature, then we divide each data item into a column with the standard deviation of the column. Here, we will name the matrix as Z. Then we calculate the covariance of the matrix Z. Calculate the Calculating the eigenvalues and eigenvectors After calculating the covariance, then we calculate eigenvalues and eigenvectors. Eigenvectors or the covariance of matrix are the directions of the axis with the high information, and the coefficients of these eigenvectors are defined as eigenvalues. After calculating eigenvalues and eigenvectors, we sort the eigenvectors. We will take all the eigenvalues and will sort them in decreasing order, which means from the largest to smallest, and simultaneously sort the eigenvectors according to the matrix P of eigenvalues. The resultant matrix will be named as P star. After calculating and arranging the eigenvectors and eigenvalues, then we calculate the features or principal components. Here, we will calculate the features. To do this, we will multiply the P star matrix to the Z matrix. In the resultant matrix, we obtain Z star matrix, and each observation is the linear combination of the original features. Each column of Z star matrix is independent of each other. Remove less or unimportant features from the new dataset. After calculating the principal components, we remove the unimportant features from the new dataset that is generated. So, applications of principal component analysis. Principal component analysis is mainly used as dimensionality reduction technique in various AI applications such as computer vision, image compression, etc. It can also be used for finding hidden patterns if data has high dimensions. Some fields where PCI is used are finance, data mining, psychology, etc. Some real world applications of principal component analysis include image processing, movie recommendation system, optimizing the power allocation in various communication channels. Thank you.